All right, this is 6.5 inequalities in 103. And so when we solve equations, usually we have one solution. And now when we solve inequalities, we're going to have many solutions. And so we have to know our inequality symbols, and we have to know whether we're going to have open or closed circles. So an open circle, which is indicated like this, means that the number is not included in the graph. So when I say x is greater than 3, that's any number that is bigger than 3, but not including 3. And then when I say less than or equal to or greater than or equal to, that gives me a closed circle, and it means that the number is included. So when x is less than or equal to 2, that means that it's going to sit on that number 2, and then anything less than that. So two things that you want to know about your pointer is that when you have an inequality symbol, this right here is the pointer, and that tells me which direction I'm either going to shade or dot on my graph. If I'm going in this direction, the pointer is now facing this way, and so I'm moving like that. So there's two things that you need to know about these problems. One is that you're going to be looking at the very beginning instructions where it tells you what kind of number x is. So if x is a real number, then you will shade the graph. That means it includes decimals, that means it includes fractions, and you will have shading on the graph. So the very first thing that we're going to do is just learn how to represent this inequality. So when I want x is less than 4, this symbol right here tells me that it is an open circle because 4 is not included. So I'm going to put an open circle on the number 4. And then because the pointer is going in that direction, that's going to be the direction that I'm going to shade. And now these are going to be multiple choice, so you're just going to have to choose the correct graph. And they're going to give you an open circle shaded to the left, an open circle shaded to the right, a closed circle shaded to the left, a closed circle shaded to the right. And you're going to just make sure that you pick the correct one. Okay, greater than or equal to means that the number is included, so it will be a closed circle. So we're going to find the number 3, negative 3, excuse me, and then we are going to the shade to the right direction because the pointer is going to the right. Now, those are for if x is a real number. If x is an integer, that means that it's only numbers on the number line. So I like to refer to those as dots, okay? Fractions and decimals are not included. Okay, they're not integers. So the only numbers that can be marked on the number line is the actual numbers that you see. So when it says x is less than or equal to 1 and it's an integer, this means that 1 is included and there will be a dot on positive 1. And then a dot on every number to the left of it. Now they'll have 3 dots up here which will shade in this arrow. So with x's being an integer, it's either going to include the number or it's not going to include the number. There are no open and closed circles when x is integer. So no open I should say no open circles. No open circles when x is an integer. Okay, so again, we look, x is an integer. It says x is greater than or 8, so 8 is not included. So that means it's going to start at the first integer that's larger than 8, which would be 9. And then you would have your dots, which would then shade in that arrow. Okay, now to solve a linear inequality, just like an equation, whatever we do to the left side of the inequality, we have to do to the right side of the inequality. But unlike an equation, we always want our variable on the left, followed by our inequality symbol, followed by our number. Okay, that's the order that we want. So when I look at this and it says x minus 6, I'm going to add 6 to both sides. That disappears, and x is greater than or equal to -5. Then I come up here and I see x is a real number, so that means I'm going to shade. And then this means that it's a closed circle, so I put a closed circle on -5, and then I will shade to the right. Okay, so now we're still working with x being integer, or sorry, not x being real numbers. So I'm going to subtract 11. Oops, I don't know what happened there. I'm going to subtract 11. And so then I get x is less than 4. 4 is not included, so it's an open circle, and then I will shade to the left. Okay, now it's going to say x is an integer, and so that means I'm going to dot. So I'm going to write dots, and I'm going to subtract 4, and so x is less than or equal to -3, which means it is included. So there will be a dot on -3, and then every number on the number line that's to the left of -3. And that's it. Okay, now the only rule that changes with inequalities is the multiplication property or division property. And so if we look at a true statement such as 5 less than 10, and we multiply both sides by 2, we still get 10 is less than 20, which is true. However, if we multiply by a -3, 5 times -3, 10 times -3, that says -15 is less than -30, which is not true. -15 is greater than -30. So here's the rule that we have to remember. If you multiply or divide by a negative number, you must reverse the inequality sign to make it a true statement. Okay? So as we go through, we look, x is a real number, so I'm going to shade. I'm going to divide by a -3, and as soon as I divide by a negative, I reverse that inequality symbol. And so now I get x is greater than or equal to -4. So that includes -4. And then I will shade in the right direction. So if you don't flip the inequality sign, you will have your inequality wrong, but you'll also have your graph wrong because it'll be going in the wrong direction, okay? Now, don't think that you flip the inequality sign if you see a negative. You only flip it if you divide by a negative. So here I am dividing by a positive number, so I do not flip the inequality. And I look, it says x is a real number, so that means that I'm going to be shading. I get my closed circle on -6, and I will shade to the left. Okay, now we see x is an integer, so I'm going to dot. I am going to divide by a -12, and so I must reverse that sign. So now I get y is greater than +4. And because it's an integer, 4 is not included. So that means the first number that will get a dot is 5. And then we will go in the right direction and dot those numbers. If you have a fraction, remember how to clear a fraction. You will multiply both sides by 3. And so that gives me x is greater than 15. X is an integer. This is not included. And actually I have to extend my graph here, so let's extend it. And let's put those numbers. Let's just start 15, 16, 17, 18, 19. And I will dot starting at 16 and going in the right direction. So again, these will be multiple choice. You'll have to just choose the correct graph. Okay, now they get a little bit more complicated, and remember that you're looking for whether it's a real number, you shade, or whether it's an integer, you dot, okay? So now we've got some multi-step equations. We're going to undo the minus 3 first by adding 3. That gives me 5x is less than or equal to 20. And then I'm going to divide by 5, and x is less than or equal to 4. And since I'm shading, I will have a closed circle on 4, and I will shade to the left. Okay? X is a real number. I am going to subtract 2. So I get 3x is less than or equal to 12. And then I'm going to divide by 3. And so x is less than or equal to 4, which is what I just graphed. So we have closed circle on 4, and then we shade to the left. Okay? All right, so now we have variables on both sides, and remember the goal is we want variable on the left, inequality symbol in the middle, and then our number on the right. So I'm going to actually move the 13x by subtracting 13x from both sides. That gives me negative 6x minus 3 is greater than 33. And then I'm going to add 3 and come up here. And so now I have negative 6x is greater than 36. I'm going to divide by negative 6. Ding, 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 ding. That means that I have to reverse. And so I get x is less than negative 6. Come back here and check to see what I'm doing. And so I will be shading. So it is an open circle on negative 6. And then I will shade to the left. Okay? All right, so the next one, we're going to move the 4x. So I get 2x minus 2 greater than or equal to 6. I'm then going to add 2. And so I get 2x is greater than or equal to 8. And I divide by 2, and x is greater than or equal to 4. And then I look over here. X is an integer, so that means I'm going to dot, and I'm going to include the number 4, and there will be a dot on every number after 4. Okay, x is an integer, means I'm going to dot. And I am going to subtract 3. So be careful because there is a negative number in front of that x. Negative x is greater than or equal to negative 6. In order to get rid of that negative 1, we are going to divide, which means I'm going to reverse the sign. So x is less than or equal to 6. And that means 6 is included. And then I'm going to have dots on every number, that's a lot of numbers, to the left of positive 6. Okay, as they get more complicated, you just have to watch your, Order of operations, we always get rid of parentheses first, so I'm going to distribute so that I get 2x minus 6 minus 1 is less than or equal to, and then I'm going to distribute 3x plus 6 minus 14. Now I have to collect like terms on the same side, so we get 2x minus 7 is less than or equal to 3x minus 8. I'm going to subtract the 3x, and so I get negative x minus 7 is less than or equal to negative 8. Let's add 7 to both sides. Come up here, and I'm going to get negative x is less than or equal to negative 1. And then I'm going to divide, which is going to change that sign. And x is greater than or equal to positive 1. So that means 1 is included. I am using integers, so I am going to dot each number that is on the number line. All right, one more, and then we're going to get to two special cases. So I get 4x plus 4 plus 2 greater than or equal to 3x plus 6. So then I get 4x plus 6 greater than or equal to 3x plus 6. I'm going to subtract 3x. So I get x plus 6 greater than or equal to 6. And it's okay to get 0, and that's what's going to happen. I'm going to get x is greater than or equal to 0. I see x is an integer, so I know I'm going to dot, and I'm going to have dots on everything and including 0 to the right. So luckily, you guys don't have to dot these. They'll be dotted for you. Now, here are two special cases, and I'm going to have you recopy one because I made an error. So when you recopy this, this one you don't have to recopy. What's going to happen is something special is going to happen. And so when I distribute this, I'm going to get 8x minus 4 is less than 8x minus 6, okay? And so when I have the same number of x's on the left and the same number of x's on the right, they will cancel out. And now I have negative 4 is less than negative 6, which is not true. So there is no solution for this, and the graph of no solution is an empty line. No shading, no dots, okay? That is not true. Negative 4 is not less than negative 6, so we cannot have anything shaded on our graph. Now, the last special case, I want you to copy this problem because I made an error. So it should be 4 parentheses 2x minus 1 less than or equal to 2 parentheses 4x minus 2. Okay, so we're going to distribute it, and we're going to get 8x less than 4, or 8x minus 4 less than or equal to 8x minus 4. Again, the x's will cancel each other out, and now I have that negative 4 is less than or equal to negative 4, which is true, okay? Now, we usually don't say negative 4 is less than or equal to negative 4, but because it includes it, it is true. That is a true statement. If you work this out and you got a statement such as this, 5 is less than 10, that is true, and that means that every number on that number line will make a solution. So this is all real numbers. And so since we are shading that means the entire line will be shaded. Okay, now it could be the entire line is dotted if it says it was an integer, or it could mean that the entire line is shaded if it says it's a real number. So I'm going to stop there, and then we'll do compound inequalities in another video.